Probability and statistics are the mathematics used to understand chance and to collect, organize, describe, and analyze numerical data. Probability is the study of random events. It is used in analyzing games of chance, genetics, weather prediction, and a myriad of other everyday events. Statistics is the mathematics we use to collect, organize, and interpret numerical data. It is used to describe and analyze sets of test scores, election results, and shoppers' preferences for particular products. Probability and statistics are closely linked because statistical data are frequently analyzed to see whether conclusions can be drawn legitimately about a particular phenomenon and also to make predictions about future events. Let's move now to distributions. The binomial distribution. Binomial distribution can be described as the probability of a success or failure outcome in an experiment which is repeated many times. The binomial distribution has two possible outcomes, such as a coin which has heads or tails. The formula of binomial distribution is as shown, where n equals number of trials, x equals number of successes desired, p equals probability of getting a success in one trial, q equals probability of getting a failure in one trial. Three criteria should be considered in binomial distribution. The number of trials should be fixed. Each trial must be independent. Probability of success is exactly the same in all trials. The Poisson distribution. Poisson's distribution is a discrete probability distribution that measures the numbers of an event occurring in a specified period of time or space. For a given time interval, the random variable x may represent the number of telephone calls per hour. The number of days school is closed during winter. For a specified space, the random variable x may represent the number of bacteria in a given culture, the number of typing errors per page. The formula of Poisson's distribution is as shown, where lambda equals mean number of occurrences in the interval, x equals any whole number. The properties of Poisson's distribution. The outcome can be classified either success or failure. The average of successes occurs in a region is known. The likelihood that a triumph will happen in a minuscule area is zero. The normal distribution, also called the Gaussian distribution, or sometimes called the bell curve, is by far the most commonly used distribution in statistics. This distribution provides a good model for many, although not all, continuous populations. The normal distribution is continuous rather than discrete. The mean of the distribution determines the location of the center of the graph, and the standard deviation determines the height and width of the graph, and the total area under the normal curve is equal to 1. The probability density function of a normal random variable with mean mu and variance sigma squared is given by the formula shown. Note that the normal curve is symmetric around Greek letter mu, so the Greek letter mu is the median as well as the mean. It is also the case that for any normal population about 68% of the population is in the interval mu plus or minus sigma. About 95% of the population is in the interval mu plus or minus 2 sigma. About 99.7% of the population is in the interval mu plus or minus 3 sigma. Let's talk about the applications of normal distribution in real life. Height. The number of people taller and shorter than the average height people is almost equal, and a very small number of people are either extremely tall or extremely short. Rolling a dice. A fair rolling of dice is also a good example of normal distribution. IQ. The IQ of a population is a normal distribution curve, where IQ of most of the people in the population lies in the normal range, whereas the IQ of the rest of the population lies in the deviated range. Birth weight. The normal birth weight of a newborn ranges from 2.5 to 3.5 kilograms. Most newborns have normal birth weight, whereas only a few percentages of newborns have a weight higher or lower than the normal. Shoe size. In the US, female shoe sales by size is normally distributed because the physical makeup of most women is almost the same. Students' average report. The average academic performance of all the students, and in most cases, it follows the normal distribution curve. The number of average intelligent student is higher than most other students.